Hey guys, welcome. This is going to be a video for the flat earthers. With the whole final experiment thing that happened, a lot of flat earthers are finally realizing that the AE map just can't work, it doesn't work, and you guys are looking at this other model. It's called the dual pole model. Basically, you've got two real poles. And the world works a little bit differently. What I've done here is I have a 3D model of both of them. Both of them I have here animation for daylight and nighttime for the entire year. I have, and no one else has been able to do this outside of a model like Walter Bisland's model. I have a 3D model here, 3D environment set up with two different cameras, and I'll go how I did this in the end, but let's go ahead and start the animation and look at what we're looking at. So I'm gonna start talking really quick when I play the animation, okay? Let's put the animation at let's put 60 frames a second. All right, let's go. So what are we looking at here? As you can see, we've got day and night happening really quickly. Let's pause here for a minute. What do we have here? Look, so we've got daylight here and we've got darkness here, okay? Let's just focus on this one here. It's rotating. If you notice, there's 24-hour of darkness in Antarctica and 24-hour daylight in the North Pole. Let me take the animation back to the beginning. You notice this here? Based on what we're seeing here, I haven't told you guys what time of the year it is, you know, what part of the season it is. Just from what we're looking at here, we already know we're at or we're near the summer solstice, which is around the month of June. Simply because of we're seeing the 24-hour daylight in the North Pole and 24-hour darkness in the South Pole. We also have this happening here at the same time on the AE map. If you notice, there's 24-hour daylight here and there's 24-hour darkness in the outer edges of Antarctica. So these two models, they're showing the same exact thing at the same exact time. Now what's going to happen is the sun is going to, so we're going from June to July, August, September. September is the equinox, okay? What's the equinox? The equinox is when the sun's going over the equator and you've got equal day and night. And let's see if we're there yet. So we know the equinox on the flat earth is when it's 50-50 light up. So it's still not 50-50 lit up right now. Let's let it keep going a little bit. Let it keep going a little bit. So we're basically almost there. We're almost basically at the equinox, 50-50. Notice Antarctica now, it's half of it is lit up. Notice is lit up as well. So now we could say we're a little bit past it now, but now we're at the month of September, okay? Now we're gonna go into the winter solstice. This is the big problem for the AE map, and no one's been able to model this so far, outside of the Walter Bisland map, which is done with forced code. Now, if you notice here, we already are starting to have 24-hour daylight in the most center part of Antarctica. You see? And we're already starting to have 24-hour darkness here in the North Pole. So we're going closer and closer and closer to the winter solstice, December 25th. We've got 24-hour daylight in Antarctica here, 24-hour darkness here. Let's look at the AE map now. You guys are looking at this? 24-hour darkness in the North Pole, 24-hour sun in Antarctica. So Antarctica, some of it is a little bit cut off from the map, but you could imagine the outer edges, they're completely lit up. So we're pretty much around or at the winter solstice at this point. Check out this animation for the AE map. Even though we know the world's not like this, even though we know the AE map doesn't work, it's still really nice to see this animation here. Check this out. Look at the other one. So now we left December. Now we're going back towards March. So we're probably in January right now. We're going back towards the spring equinox, which is in March, which again, it's on the AE map. Half the world is lit up. It's going. We're almost there. So we're approaching equinox right now. We've now passed equinox. Now we're starting to 24 hours daylight will start to occur in lower and lower latitudes from the North Pole. And then for sake of time, well, I guess we're at the end. We could let it play out. Okay, you guys, if you've made it this far, I hope you've enjoyed it. Thank you very much. I do want to show you how I was able to do this. This is a big secret, and you need to know, okay? What you're seeing here, it looks like I've got two different models here. This is one model. This is one 3D model. Get ready. Here's the secret right here. I have a concave Earth 3D model here. There's only one model in this scene. I have a concave Earth model, okay? Here's the magic. We have two cameras. One camera here in the middle of Antarctica. This is the AE map. This camera is looking up, which is what this is here. This camera is looking up. You've got the AE map here. This camera, and then we've got another camera which is situated at the opposite side of Africa. So somewhere here. Check this out. Look at that. There's the other camera right there. I'm selecting it. You see? Looking at the opposite side of the world. If this theory is true, the AE map is not a projection from the globe. The AE map is a projection from the concave Earth. And the Pac-Man model is also a concave Earth model. The Pac-Man model is an observer situated inside of the concave Earth, looking across to the other side, and via this setup, you're able to recreate daylight and nighttime. Because I have daylight and nighttime set up for concave Earth, I'm now able to have three models in one. So for those of you that have recently graduated from the AE map to the dual pole map, I want to congratulate you. You've made a big leap. It's a big leap to understand Antarctica is more this size and not that size. It's important to understand that there's two universal axes of rotation for the stars and for the atmosphere and for everything else. One in the north and one in the south. It's important to know stars rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere around there. Long story short, you are ahead of the pack for knowing this AE model, for knowing this dual pole model. AE map, dual pole map, and soon you will graduate to concave Earth. Thank you guys very much. I hope you've enjoyed this video. You guys have a great day.